All right. Well, thank you so much, Cody. I really appreciate you having me. And yep, just wanted to get my live stream started here, and we are ready to go. What I'm going to be talking about today is my experience as a software developer building my first Ethereum smart contract. And so I'm going to be talking about building this contract from the perspective of somebody that has very minimal Ethereum experience. And so I think that's going to give it kind of an interesting flair versus maybe hearing how to build a smart contract from somebody who's an expert. I'm sure that technically might be better, but I think it's always good to, as a tech educator, hear from and understand the experiences of people that are actually going through learning something for the first time. So a little bit about myself. I'm a full-time software engineer at Microsoft in Pittsburgh. So I work under the Azure team. I was a part of the team that was acquired from Avere Systems. It was a Pittsburgh-based startup. My day job has nothing to do with crypto or blockchain, but it's a topic that I'm really interested in as a computer science professional. And so on the side, I run Chain Toots, which is this project, and I create cryptocurrency and blockchain related tech education content. So I create articles, videos, little code projects that are kind of standalone and help explain different concepts. I'm on a couple different platforms, I would encourage everyone, if you like this content, go check those out, subscribe and share and those sorts of things, and help get the content in front of more people. And my particular focus is really on understanding and teaching kind of the core concepts. So I don't really get involved in any speculation or finance stuff. I'm more interested in kind of helping people that are interested in these platforms understand what's really happening under the surface and how they might find different use cases. Quick disclaimer for this talk. I'm not an expert in smart contract development, as I mentioned, and in fact, I'm not even close to intermediate at smart contract development in particular. But I am a professional software engineer, and so I want to give my perspective on building a beginner smart contract as a beginner. So we're going to start by talking about some general concepts around computer programming. I know y'all are here specifically for Ethereum, but I think it's going to be interesting to tie in and compare and contrast what it's like to write your first computer program just in a generic sense for a desktop or a smartphone versus developing on a smart contract platform like Ethereum or one of these other distributed blockchains. So computer devices, maybe if you're not a programmer and you're just coming in to hear about this as an Ethereum enthusiast, computer devices don't do anything on their own. In order for a computer, for a smartphone, even for a programmable blockchain to do anything, we have to program them with explicit instructions. Your laptop, your phone, your car, all require instructions that will be interpreted by a CPU to make it do something. That can be calculations, display, accepting inputs, etc. And you don't have to learn this machine code, however, for every device that you're going to program. We have abstractions in the form of programming languages that help you deal with that in a much, much easier way for a human. So what we've done is we've built layers between the machine code that every platform runs and the high-level languages that we use. I don't have to know x86 assembly to code on a laptop. I can learn C, I can learn C++, Python, Java, JavaScript, any number of languages, which are all translated to the machine that you're actually wanting to execute the code on. There are three major categories of computer programming languages that we're going to talk about, and we're going to talk about where Ethereum smart contracts fit into these types. There's compiled languages, there's interpreted languages, and there are intermediate type languages that use bytecode and a virtual machine, which is in some ways a little bit of a hybrid of the two. Compiled languages are the ones that are the most performant and are fairly common. So this is C and C++. These instructions that you type out for a C or C++ program are read by a software program called a compiler and translated directly into machine code for the target platform. You have to recompile this code for every target platform or operating system that you want to run on. So if I want to compile a program for Linux running on a Raspberry Pi, which is an ARM chip, I have to compile specifically for that. If I want to compile a program to run on a Windows laptop, which is x86, maybe 64-bit instructions, I have to recompile for that again. The advantage of compiled languages is that they tend to be the most performant. So since you spend the computing power ahead of time on compilation, you get a program that will actually execute much faster. So these types of languages are most commonly used for things like scientific applications, computer games, distributed systems. Anything that needs to be able to operate as fast as humanly possible will be done with a compiled language most generally. Now, the next type that we have are interpreted languages. These are languages such as Python or JavaScript. In these cases, instructions are read line by line by a special program called an interpreter. They're read and then they're translated into the system calls needed to actually make the program do something at the machine level. So the interpreter translates instructions on the fly, and there's no need for compilation, just an interpreter available on that system. So for example, you might have a Python interpreter on Windows, Linux, or a CircuitPython device, or JavaScript in your web browser. The advantage of this is your code tends to be more portable, so you only have to write the code once, and then you can use an interpreter to run on that system. The final type that we're going to talk about is intermediate languages like Java, C#.NET, or Solidity. In this case, instructions are compiled into an intermediate language called bytecode language. So this is similar to interpretation and compilation in some ways because the instructions are compiled first, and then the virtual machine will interpret and recompile those bytecode instructions to the target machine. There's various strategies for doing this that I'm not going to get into, and I'm really not really qualified to talk about. But for example, Java compiled on a Windows machine can be executed on an Android phone. C#.NET can be compiled on Windows into intermediate code and then run on an Xbox 360. That was something that existed a few years ago with the XNA Game Studio. So now let's get to the fun part and the part that you're all here for, which is talking about programmable blockchains. Many blockchains, in fact, that we use and that we're fascinated with are programmable. Bitcoin and Bitcoin Cash even, although they're not thought of as smart contract type platforms, they use an interpreted language called script to execute transactions, and there's different instructions in there. So the fact that script is required to execute transactions or transfers of value is what allows for these different types that we see, like legacy transactions, multi-sig, segregated witness or SegWit transactions on BTC, and things like SLP tokens on BCH. Ethereum is programmable, though, on a much deeper level than Bitcoin or Bitcoin Cash are. Ethereum has what's called the Ethereum virtual machine. This is an intermediate language for running smart contracts that are compiled into Ethereum bytecode. So talking about our three types of programming languages, Ethereum falls. You can write smart contract code using a couple different languages that have been developed for the Ethereum virtual machine platform. The most popular being Solidity, which is the one that we're going to walk through a sample with today. And as well, there's one called Viper that's fairly popular that has a similar syntax and feel to Python. In either case, you write out the smart contract in this higher level language, and then you compile that smart contract code down into bytecode for execution actually on the blockchain. There are some key differences between coding in a typical programming language, say Java or C++, and using the Ethereum virtual machine. So let's talk about some of those key differences between programming for a typical device like a personal computer or a smartphone versus programming for a platform like Ethereum. The first one is cost. Execution on a PC is cheap. You can get a machine and it can do, an almost unlimited amount of work in the serviceable lifetime of that device. So you can run computer games, you could run mathematical calculations if you want to. You can do Zoom meetings and live streams to teach other people about programming Ethereum. And it doesn't really cost you anything other than the upfront cost of the device itself and therefore the CPU on an underlying level. But every operation on Ethereum or another distributed smart contract platform costs what's called gas. And that's a unit for measuring the compute resources used by executing the contract. Because every operation in a smart contract transaction that's executed costs gas, which is a scarce resource, you wouldn't want to use Ethereum for some compute-heavy performant code. If you need to run out mathematical calculations, there's really no reason to use a distributed blockchain, a decentralized blockchain for that task. Go rent an Azure VM for that. The next topic is actually not a difference, it turns out, and that is the topic of Turing completeness. Turing completeness is kind of an abstract concept, and I'm not even super comfortable talking about the very strict definition of Turing completeness. But you can think of it in a practical sense as the ability to use things like loops in code. A Turing-complete language will allow you to loop infinitely in a program. So like in C or C++, you could run a while loop that's just while true, and it can execute forever. Bitcoin script is non-Turing complete. It cannot loop forever. So it might perhaps be more obvious then why this is a really important thing in the world of a decentralized distributed blockchain. If somebody could code a smart contract that can just loop infinitely, they could just tie up the entire Ethereum platform, right? They could write an infinite loop, deploy it in a smart contract, and all of a sudden nothing would get done on the Ethereum network because every single node and miner out there would be trying to validate a transaction that would never finish executing. But Ethereum deals with this in a really simple but intelligent way, and that is by imposing gas limits on transactions. So every transaction can only consume up to a certain amount of gas, and you have to pay for that gas, which is, as the Ethereum network grows, becoming a more scarce and more expensive resource. Ethereum is Turing complete in the sense that the Ethereum language does allow you to use looping and these other kind of constructs that any other Turing complete language would. So it's not actually a difference between other languages, but again, because of this problem of doing this on a distributed blockchain, it's something noteworthy to talk about. And Ethereum deals with that again by locking up or setting a gas requirement so that someone cannot lock up the network resources infinitely. And a third and interesting and important distinction is that of the idea of determinism. A PC program, every time you load it, can execute differently. So, for example, think about a computer game with some random elements. Think about playing the game Pokemon, right? Every time you go into the grass, you get different random encounters with Pokemon that pop up. You could be playing a PC-based poker game or something like that where there's obviously randomness involved. But that doesn't work well on a distributed blockchain. Remember that we're running this decentralized network, and in order for this to work, every node on the network has to be able to validate transactions and verify that the end result follows the rules of the Ethereum protocol. So it's a must that every time a smart contract executes with a transaction, that transaction has to be able to replicate and execute the exact same way on every node on the network every time, so that transactions and then that history in the blockchain can always be validated. So smart contracts are always going to execute the same for a given transaction. If you create a transaction that calls a smart contract function, every single node on the network is going to be running and validating that transaction, and it has to execute the same way and end up with the same state or the same result in order for it to work in this decentralized context. So that's definitely something worth noting, and that's something that's going to come up in the example that I'm going to talk about. So let's talk about actually building one of these. My idea that I had to try this out for the first time, I always like to build little projects that are kind of useful for myself, at least in some little way. So I got the idea to implement a basic dice roll smart contract. So all I want this to be able to do is I call a smart contract function and I get back a return value that is seemingly random. This is not for cryptographic purposes, between 1 and 6. I just need a basic contract for this. I'm not modifying any state or anything like that. And I'm going to use it for something fun. I built a little backyard skills park for mountain biking and mountain boarding in my yard over this quarantine period. And I thought it'd be fun to tie it in with a tutorial. So I'm going to use this dice roll to randomly pick some of the features to practice on. So let's talk about the code then. This is fairly short. It's only about 4 slides worth of code here. So I'm just going to step through and talk about what this basic contract does in Solidity code. I start off with this pragma Solidity, and this tells the Solidity compiler what version I would like to use. It's just like versioning with C or C++. As time goes on, new features might be added to the standard. Features could potentially be removed from the standard, and so this says, hey compiler, I want to use this specific version of Solidity when I do this bytecode compilation, so I know exactly what my end result's going to be in terms of compatibility. You declare a contract. In this case, we are declaring contract bike park dice, and we have some braces, as this follows kind of like that C, C++, Java style of scoping that uses braces rather than indentation like Python and I believe Viper would use. Next, we're declaring our specific function that we're going to call. This is going to be the only function in this contract since it's a really simple one, and it just uses some seed data and some hashing functions to return a pseudo-random number from 1 to 6. The function is called roll dice. It's a public function, so it's accessible to be called by creating a transaction or through a view. And it is a view function. I'll touch on that a little bit more later, but what this means is this is a function that only gives you some return data. It does not modify the state of the Ethereum blockchain. And it returns a uint 256 called final roll. So that's a 256-bit integer number. So we need some kind of pseudo-random data to get something that's like pseudo-randomness to work on a blockchain. Remember that I just said when you execute a smart contract for a particular transaction, every time that transaction is going to come out the same way. So a way to get the appearance of pseudo-randomness in the context of a smart contract is to take some data that's going to differ from transaction to transaction and use a hashing function to give us a seemingly random output. Hash functions are one-way functions that take some input data and give an evenly sized output. And the properties of good cryptographically secure hash functions, like the ones we're using here, means that you can't predict what the output is going to look like from any given input data. This is called pre-image resistance. So if I have some output, some hash output, I can't tell that if I give the input hello, what that output is going to look like. So this is going to help give us this appearance of pseudo-randomness in this context, where we can't actually use any kind of normal pseudo-random number generation because every node on the network that runs this transaction has to be able to see the same output. So I'm taking the message.sender, the block difficulty, and the block timestamp for this particular transaction, and I'm using this abi.encode pact, which simply transforms that data into a binary data that can be hashed. Keck 256 is it was a candidate for the SHA-3 hashing standard, and it's used throughout Ethereum for their mining and address operations and things. And so that's the hashing algorithm that we're using to give us this final data. So we end up with a final hash that we run. We combine all the seed data, so the message sender and all that information, into kind of just one binary chunk, and then we run it through Keck 256 and get our final hash. Now this hash is in a bytes format that's not really usable for what we're doing. So the next step here is to cast that data type, that hash value, from bytes to a integer data type. So that's this uint256 is a 256-bit integer. That's kind of a special thing that's available on Ethereum that's nice. Most PCs these days are 64-bit, and so the biggest native integer data type that you get is usually a 64-bit int, and you have to use special libraries and those sorts of things to deal with larger integer numbers. But Ethereum allows 256-bit numbers built in because 256-bit hashes are a pretty common part of the cryptography and things that you do on a blockchain. So finally, we return a number from 1 to 6 by using the modulo or remainder function. So if you've never programmed before, this is a super common way to deal with like pseudo-random numbers. So say you're programming a normal game, maybe you're programming a dice game in C++. The rand pseudo-random function is going to return a pretty broad swath of numbers that's going to be beyond the 1 to 6 that you want. So what you do is you use the modulo operator. What that operator does is when you divide a number by another number, you have some remainder, if you think about it in pure integer math. Like if you look back to elementary school when you first did division, they didn't talk about 3 divided by 2 being 1.5. They would say that 3 divided by 2 is 1 with a remainder of 2, I think is how that would work out. I'm a little rusty on my elementary school math at this point in my life, but you get the general idea. So we get some remainder, and then we add 1 to it because the modulo function is going to give you a remainder between 0 and 1 less than the target number. So if you do modulo 6, you're going to get 0 to 5, and we want our dice roll to be from 1 to 6. So in that case, we're simply adding 1 there. And finally, we return the final roll. So let's talk about the part that you might be even more curious about is how do I do development and testing with Solidity and developing Ethereum smart contracts versus how I might normally develop for a PC. What I did as a first-timer is I used the Remix IDE, which is available at remix.ethereum.org. So this is a development environment that's totally online, and it has a built-in Solidity compiler and JavaScript VM for testing. I'm, as a programmer, somebody that's been programming for well over 10 years now, I tend to be a power user, and I like to use command line scripts and Vim and those sorts of things. Those kind of tools where you have more control over things. And I think that that might be something I would get to as I developed my ability to write smart contracts. But using an integrated development environment, an IDE, generally it gives you a really robust tool set that's a little bit more beginner friendly and has a lot of nice features that will help you out as a developer doing something for the first time. So I thought this was a really nice way to write this contract. So I didn't need to actually deploy this contract to Ethereum or even the real Ethereum testnet to experiment with it. And the reason that I didn't really have to do that in this case is I could just easily call this function and test the return value that I was looking for. I mentioned earlier that I was going to talk about this in more detail. There's two types of functions in an Ethereum contract. And the first kind is the kind that we developed here, which is a view function. This is a function that can be called just on any local node, like maybe you're running an Ethereum full node with Geth or something like that, using a API such as web3.js. When you make this function call against a contract, it just maybe does some calculations for you and gives you a return value, but there's no change in state to the Ethereum blockchain. Now, the second type of function call are ones that do actually change the state. So a simple example you could think about is an ERC20 token. So there are many, many tokens that are built on top of the Ethereum platform. And when you maybe send some ERC20 tokens, what's actually happening underlying on the Ethereum platform is that it's calling a send function on that smart contract, and it has to update the state of the Ethereum blockchain to say, okay, Josh originally had 20 of this token, and he sent 10, and so now he has a new balance, a remaining balance of 10. That state is written out to the Ethereum blockchain when this transaction is processed in a block. And so the rest of the world sees that new state change. They see that new balance that you have only 10 tokens left, so you can't do something like double spend your tokens. If you want to get a return value from one of these functions, you have to use a more complex mechanism. You have to call the transaction via a function, and you have to use a watcher to see when the return comes back. It's I didn't dive into it too deep, but it seemed to me to be very similar to doing asynchronous programming in JavaScript, for example. So if any of you that are listening have developed in JavaScript, there's many cases where you want your browser to maybe do a calculation or something, but you don't want to hold up the whole web page for that calculation. So you allow the JavaScript interpreter to do that in kind of a different thread. You allow it to do that asynchronously, and you have a callback function that when that async function is done doing its thing, then you watch for it to finish and you get your return values and that sort of thing. So here's some screenshots of me using this test JavaScript VM, calling roll dice and getting a couple different examples, a couple different sample outputs like 6, 1, and 3. Of course, I mean, writing a smart contract for the first time and testing it in a virtual environment is really cool. I mean, it's always cool to see code that you wrote working and running. That's one of the most satisfying things about programming. But we want smart contracts that can work in the real world. So how would I actually go about deploying this to the Ethereum platform? So what you would do for real is you would use a Solidity compiler to compile your contract code down into EVM bytecode. Again, that's that intermediate language, that intermediate bytecode that the Ethereum platform really understands. You take that bytecode and you create a transaction with that data embedded in the transaction, and you send that to a special address called the 0 address. This is the address that is literally 0x and then all zeros. You then have to wait for that contract transaction to be mined in a block. And so on Ethereum, blocks are processed about every 15 seconds. Depending on network congestion and the gas that you set, you could see your contract available pretty quickly. This is going to return a contract address, and so your contract is going to live at its very own account with its very own address. On Ethereum, there's these two different types of accounts. There's externally owned accounts, which is your address that you have in a wallet that you as a human send and receive Ethereum from. So that's an EOA. And there's contract addresses, which are only owned and operated by a smart contract itself. So you can send transactions to that smart contract with data embedded, and that allows you to call and execute smart contract functions. But like, you don't have the power, even as the developer, to really send or send money out of that EOA account or anything, at least as far as I understand it. I could be wrong on that, and so anyone feel free to correct me in the Q&A. But again, the point is that a contract is going to get its own special address, and that is done when you first mine the contract by sending it off to the 0 address and waiting for a block. So again, kind of in summary on what we talked about, Ethereum contracts use a virtual machine in an intermediate language compiled from a high-level language like Solidity or Viper. These smart contracts are Turing complete and pretty powerful, which makes them unique and a little bit more useful for very complex smart contract development than a language like Bitcoin script or script on a Bitcoin fork like Bitcoin Cash, which is fairly robust but doesn't have the ability to do things like looping, which can be really important. And we put limitations on the amount of computing resources that you can use by imposing limits on gas. So nobody, even though this language is Turing complete, can write a smart contract that's going to run for days on end doing some kind of number crunching or something. Again, that would be expensive. Decentralization is not needed for a use case like that, so go run an Azure VM. I'm not going to tell you AWS or GCE because I work for Microsoft. These smart contracts are deterministic, so anytime you call a function in a particular transaction's context, every node on the network is going to see that function call execute the same exact way. This is critical for running code on a decentralized platform, and something like Ethereum wouldn't work without that property. You want to use Ethereum and leverage this global computing platform where decentralization is key. So applications that we probably know of as Ethereum enthusiasts, representing real-world assets like non-fungible tokens, creating new currencies on top of Ethereum, tokens like the Brave token, stable coins and those sorts of things. There are applications that could be used in law, decentralized finance, and all sorts of use cases that I'm not even well versed in that we could spend all day talking about. That's what makes Ethereum really special and valuable, is that it's a platform where we can do globally distributed decentralized computing. But smart contracts are not the place to do a lot of coding. We want to use them where decentralization is key, and there's a particular need to leverage a platform like this with the properties that it has. So any questions then? Again, I'm a little bit of a beginner on smart contract coding, but anything from the presentation or any general questions that you have about blockchain, I will do my best.
Not so much a question, but a great a comment on a great point that you brought up was that logic can become very expensive very quickly in a smart contract. So it's not where we want to do very complex calculations typically, or a lot of coding, as you said. So that was a great point to bring up, Josh.
Well, thank you. Yeah, I think it's very important to understand in a more general context is people that love blockchain and cryptocurrency technology. I mean, I'm fascinated by all the possible use cases, but it does not solve everything. I think it's really important to explain to people that are newcomers to the space what blockchains are and are not good for. So thank you for that. Yeah, I think it's always important to talk about the valuable use cases of something like this and what it's not so good for.
Right. When I first got into blockchain, I had the mindset of decentralize everything, but then over time, I think I quickly learned that not everything needs to be decentralized or on a blockchain, And I've kind of learned that through trial and error. But Greg, did you have something to say?
I was curious, what is something that you thought you would be able to decentralize but decided it wasn't practical or cost effective to do?
That's a great question. I don't have any particular use cases that I've encountered with like, people that I've worked with or any projects that I've worked on myself. But in a more general sense, one of the things that I hear about a lot is potential applications for blockchain in business. So things like healthcare, for example. And I think it's really, really important to explain and understand that private blockchains in particular are really a little bit dubious in the sense of whether or not they're useful. So you have to think about when you're talking about a decentralized blockchain is who are you trying to prevent from tampering with data? So again, for like the healthcare example, if you have a private healthcare blockchain and the CEO comes down to the IT people and says, we must change this bit of history in the blockchain. If your organization is the only organization that runs nodes or controls that blockchain, it's basically useless because it's a database that you still have access to and can change. Now, in the sense though, you may be able to use that, across several organizations to prevent fraud or medical malpractice or something like that, like prevent a doctor from being able to go in and change medical records to make himself look better in a medical malpractice suit. I don't know if I'm explaining that well, but like I just hear a lot about, I think people, especially in the context of business and private blockchains, want to say, oh my goodness, blockchain is going to solve all these problems for us. But you really have to drill down into a pretty specific sense of the use case within an organization to see if it's even worth it or really going to do anything. Because a blockchain without decentralization is just a really slow and expensive database. You're much better off using loads of other solutions than a blockchain if decentralization and censorship resistance and immutability are not the first class priorities for that project.
Gotcha. That makes sense.
There is some general issue of like on-chain versus off-chain too, even when you have something deployed, for instance, voting, or like voting on consensus or regular governance token voting. If you do that on-chain, that means people are paying gas to do transactions to do voting, and that it can be expensive, and it can be actually it can be very expensive to vote, especially if there are several votes a week and each of them costs $20 or $30 every time. Then people aren't going to vote unless they have it's going to disenfranchise like all the people that don't have a huge stake in it, to be worth paying that much in gas. So then there are other voting solutions that are off chain that involve just like digital signatures, like they do a snapshot and you do a signature to prove you own, the coins at this address, and then that's your vote. That's a general. That's not like blockchain or not blockchain, but that's even on the blockchain. There's an on-chain versus off-chain debate too, and a lot of it comes down to resources.
Yeah, absolutely. Again, I think it's important to say that like computing on Ethereum. So what Ethereum fundamentally is it's you hear it's called the world computer, right? It's a decentralized distributed computing platform, but it's a much scarcer resource than computing on say an Azure VM or computing on a personal desktop device with the GPU is, right? You really only want to use this for a case where the first priority in making sure this application works correctly is it will be immutable, so nobody can just tamper with this data and the result. It'll be, we need that decentralization and censorship resistance to make this thing work. If those aren't first class priorities, there's probably a pretty good chance that there's another platform that you could do your project on that would give you better results and less costly results. I'm a very much a use the right tool for the job guy. The
big use case now is holding large sums of money, like hundreds of millions of dollars. There's no way that, a company that if you don't even know who they are, you would trust them with millions and millions of dollars. But with blockchain, you can actually do that if the code's audited and you can look at it and it can't be shut down. People can't steal things. You have a lot more confidence.
Absolutely. I mean, I consider I'm someone that considers like commerce and those sorts of applications to be first priority and first class citizens on projects that I get involved with. So I'm interested in Litecoin and Bitcoin Cash and Bitcoin Digibyte and all these platforms, and Ethereum, of course, all of which have that potential to be used for value transfer, without banks, without corporate institutions, and much more securely than our like credit card system that we all use regularly. So it's fascinating stuff, and there is a lot of right and potentially wrong use cases for a technology like this. And the good news is it is a permissionless blockchain, right? So I mean, if somebody wants to spend a ton of gas on doing stuff that they could just do on a PC on Ethereum, by all means, nobody can stop them. And that's actually a really cool property of things like Bitcoin and Ethereum. But I tend to advocate for using the correct tool for the job. It's all about efficiency.
And there are absolute limits. There is a limit to it. There's a size limit and there's a block gas limit. So you can't literally do anything.
Yeah.
Unless you put it up and when gas is 400 gwei now sometimes.
Right. Yeah. Gas prices have been pretty crazy lately.
I thought 200 was ridiculous. It kind of everything grinds to a halt. I was going to do some voting and I was going to do some stuff, and the gas prices are 450 or something. I'm like, nope. It would cost me, and if you want to do some minor investment or moving things around, it costs more to move it around than it does to just leave it there, even if it's not doing well.
Yeah, it's kind of funny. My brother is also very into cryptocurrency, and I was sending him $10 of Ethereum the other day, but after transaction fees and gas costs, it ate up like $4. So he only ended up with like 6 of the $10, But so Josh, my question to you is, have you explored any of these yield farming sort of DeFi trends like Sushi Swap or anything of the sort? And could you tell us a little bit about it if you have?
Unfortunately, I haven't. I try to be informed about all the different things going on, but I try to focus on the topics that I'm most interested in, just because of just time and mental resource limitations. I do have some people that I talk to that are interested in it, but unfortunately I don't know a ton about it yet. I'm interested to learn about it, though. I see on our good friend Crypto Twitter that it's quite a popular topic these days.
Right, yes. I only asked because I myself do not know much about it, so I was just curious if you did.
Yeah, the most I'm somewhat familiar with is like the concept of staking. Somebody asked me about it the other day. Like, I kind of get the general idea of like putting up collateral and getting some rewards back because you're like, for example, on a proof of stake network that you're helping secure. But even staking is different on different platforms. It means different things. Doesn't even necessarily have anything to do with DeFi. So I'm unfortunately not qualified to talk about it.
No worries, man. No worries.
Yeah, I just launched on. Have you heard of Balancer?
I think I have actually.
Yeah, it's an asset manager. It's one of the earliest asset manager. I just launched the smart pool implementation. So it creates a pool. We call them core pools, which hold assets. And it's kind of the opposite of it's like an ETF or a mutual fund, I guess, to be non-technical. Except with a traditional finance mutual fund, it's custodial. You send money to a custodian, and then you pay them fees to manage it. And this is kind of the opposite of that. First of all, it's non-custodial, you've just, everything's in your own wallet. You're just shifting tokens around in your own wallet. You're locking tokens in the contract. So the pool is a contract, and you've got the tokens in there. And then it has an internal price system. And as the internal and external prices diverge, then there's a decentralized exchange, and then arbitrageurs will rebalance it for you. And then to do that, they're paying trading fees. So you're actually, you keep your own money, someone else rebalances it for you, and you earn fees instead of paying fees. And then you also earn like governance rewards just for providing liquidity to it.
That's pretty cool.
That's one of the big. So so the Uniswap was kind of first. Have you heard of? Has everyone heard of Uniswap?
Yep. I have.
So that's where you have, you can swap one token for another, and you have Uniswap pools, but they're 2 tokens. So Balancer is like a generalization of Uniswap. You can have up to 8, and you have an n-dimensional. It's got the same sort of math behind it, but except it's generalized to n dimensions. It's
Interesting.
got an n-dimensional curve to calculate prices.
Very cool.
Kind of fun. Yeah, it's kind of funny. I saw a quote from the Securities Exchange Commission the other day on Twitter, and it was like, some of these like DeFi things, like yield farming, are a little above my head, right? And this quote said, "If you don't understand an investment, don't invest in it." And I had to laugh to myself because, like, there are a lot of like DeFi Ponzi schemes, and which is sad that a lot of people who are brilliant writing smart contracts invest their time into creating things like this. But
because you can make $1 I guess, if they're not unscrupulous.
Right, exactly.
Right. Well, that's why we went through 4 audits at this point, which are extremely expensive and very intense. But that's at least the minimum standard to make sure that. And then you do things like, verification, so where your code is published and verified so that people know they can read it and know, that you didn't secretly put a backdoor in or something.
I just had to laugh at the SEC comment because it's like, it's don't invest in stuff you don't understand. Well, of course, but I also don't understand like mortgage-backed securities and all that stuff that caused the 2008 financial crisis that happened 12 years ago that I still have no clue how it worked, really.
Right.
Like, other than kind of spitballing high level. I don't encourage people to get into cryptocurrencies just as a speculative asset because they are volatile, but it's like, come on, SEC. You think any of us understand most financial assets these days anyway?
Right. Yeah. It's kind of funny because I think my interest and love for crypto in general is that, like, on a smaller scale, you can take like computer code, right? You can take bits of economics, and you can take these ideas from philosophy, and you can kind of replicate these, socioeconomic kind of conditions, and you can create a currency, which is beautiful. But you can see how it's created and how it functions, and there's code that gives you, definitive answers. But you don't get that in the real world all the time. Some things are so complex and so abstracted that, it would require like 10 years of working experience and profession to understand like how a mortgage works or, things like that. So.
Yeah, I know what you mean. I like code. I understand code. I built my profession around code. I mean, granted, everybody that's a software engineer also does say, don't trust us, because we've all seen our own mistakes.
Yeah.
But, I just dig in general the fact that what Bitcoin and what Ethereum are is they're really protocols for money and for distributed computing. Like, I'm just in love with the fact that this is a set of computer code, a set of just simply agreed upon rules in a community, and you agree upon them just by running a piece of software that anybody can download, even on a smartphone, and suddenly you get to participate in this mass network of money, and it's like a whole new version of the internet. I mean, of course, that's not my unique thought, right? That's Andreas Antonopoulos's concept of the internet of money, but that's just one of the best summaries I've ever seen of the whole space and the value of all this technology.
Right. Somebody else, Eric Weinstein, said that if I'm trying to paraphrase his words here, they're quite beautiful, which was that so like currency that we use today owns a monopoly on violence, right? And but like cryptocurrency is the first time that, oh man, I can't even remember how he worded it. Essentially, it's void of like human corruption in a way, you know. And I guess that's what's beautiful about it.
Right. The U.S. dollar is based on people with guns forcing people, future taxpayers, to hand over their property. Right. That's what the U.S. dollar is backed by. It's
Right.
backed by
Yeah.
the U.S. military. You know, whereas, yeah, Ethereum is backed by math and the internet, I guess, and
Just love it. It's
computing power.
money by the people for the people. That's totally. It just gives people more choice, and I'm just kind of big on that in life in general, and especially with technology. Is I like people to have choice. I think that there should be open source alternatives to commercial projects. If you like the commercial product, awesome, use it. If you want some different choice, you want a different, power over your ability to do things or control over your data, there should be choice. And I think Bitcoin and Ethereum and all these really good decentralized crypto projects are giving people a way out if they don't like the current system. It's tremendously valuable, and it's kind of fascinating to be on the ground floor of this stuff. I mean, 10 years old is very young for a piece of technology.
Absolutely.
So we're all getting to enjoy the ride. I'm 25. I'm far too young to have rode the first wave of the internet, at least from an adult perspective. And so getting to ride this wave of new technology with crypto and seeing this little baby that I find to be very cute and fascinating grow up is just so cool.
Yeah, it's interesting because on the curve of adoption, I've seen a couple different speculations on it, but like even over the course of 10 years, we're still pretty early adopters of the technology, you know? But I actually did find that quote by Eric Weinstein. It says, "Gold is born in the collision of stars, a violent activity, but not one of men. Fiat currency comes from the government, which is a monopoly on violence." And then he concludes, "Blockchain is the point at which currency has evolved beyond the violence of both stars and men." So I always really liked that quote. That was with his talk, I think with Peter Thiel, actually, that he said that. So it always kind of stuck with me.
This is getting a bit lofty and philosophical, but I'd like to contribute to this by suggesting that there's a big risk of simply creating a new divide between the haves and the have-nots. It's true all that has been said in this conversation about the equitable leveling of the playing field through the use of blockchain, but there's an analogy to people that are presently in the old paper money way, banked versus unbanked, and how those who are less fortunate often don't even have bank accounts. As we move to blockchain, that problem will be exacerbated because people who have access to technology will be the ones who win, and those who are already in a depressed state or do not have the skills will be excluded from this utopian system.
Very well said, Greg, and I'm very interested in that topic myself. I'm a big advocate for making chains like blockchain be scalable and accessible to people without banks. I like to see low transaction costs and make it so that anybody that has a smartphone and a data connection, which is possible in many of these areas that don't have access to traditional banking, as a way to enable people to as a way for people to enable having control over their own money in a digital sense. And with that said, I think it's been a really good discussion. I think we've veered off the topic a bit of the smart contract development, and no problem with that from me. But I guess I wanted to just conclude and ask if anybody had any final questions. And thank you all very much for your time. I really appreciate you all being here on a Saturday afternoon to hear what I have to say and give me the opportunity to get in front of people and teach, because it's one of my favorite things to do.
All good on my end. Thank you so much for your time, Josh. Greg, that is a fantastic point. Perhaps we could explore it in another meetup. And I just wanted to personally thank you all for coming out. It means a lot to me. And, it's great to see the community growing and interest growing. I'm sure it waxes and wanes at times. But, thank you, everybody. And if that's it, I will go ahead and conclude the Zoom. And thank you once again, Josh. And thank you all for coming.
Thanks a bunch, all. Again, you can find me at chaintuts.com. There's a contact form there. I'm on Twitter at chaintoots. Everyone, please feel free to get in touch if you have questions. I do this to help people understand this tech. So thanks again so much, Cody, for having me, and I hope to hear from you all soon.
Take care, everyone.